Webinar rund um die Übernahme von VeloCloud durch Arista. Mein Name ist Stefanie Ech, ich bin Business Development Manager im Bereich Data Center und gemeinsam mit meinem Kollegen, dem Martin Wex, er ist Key Accounter, sind wir für Arista verantwortlich. Für Sie jetzt nochmal ganz kurz zur Info. Wir werden das Webinar aufnehmen und im Nachgang an Sie verteilen, so wie auch die Präsentation, die gezeigt wird. Und wir werden alle wichtigen Kontaktdaten der Kollegen und die Informationen zum weiteren Prozess in einer Follow-up-Mail zusammenfassen und an Sie rausschicken. Sie haben auch die ganze Zeit während des Webinars die Möglichkeit, Fragen zu stellen über die Chat-Funktion. Und diese werden wir dann im Nachgang während des Q&As beantworten. Von Arista darf ich zum einen Martin Wetaller vorstellen. Er ist der Channel Manager von Arista. Und zum anderen darf ich Robert Looney vorstellen. Er ist Systems Engineer. Und er wird Ihnen jetzt einen Überblick über die Übernahme geben und Ihnen die innovativen SD-WAN-Lösungen auch von VeloCloud vorstellen. Robert wird das Webinar in Englisch halten, also bitte beachten Sie das nochmal. And so now I will hand over to Robert. So the stage is yours.
Thanks, Stephanie. Good morning, everyone. My name is Rob Loney. I'm a solutions engineer at Arista Networks. I came across with the acquisition of VeloCloud back in July. Previous to that, I've been with VeloCloud for 7 years. Sorry, can you see my screen? Can you see my screen? Yeah.
Yes, we're able to see a screen, but it's not in presentation mode.
Yeah, sorry, I'm not sure what happened there. Sorry. Okay, is that better?
Yes.
Okay, good. Okay, so yeah, sorry about that. So yeah, once again, I'm Rob Loney. Nice to meet you all. Good morning. I'd like to talk you through today's webinar. Just really I've put together this agenda talking about VeloCloud and Arista, the reasons behind the acquisition, why Arista acquired VeloCloud back in July, give you an overview of the VeloCloud solution, talk about the key differentiators of our solution, and then talk a little bit about secure SD-WAN, so some of the additional capabilities that we've added to the VeloCloud solution over the last year or so in terms of security. So without further ado, I'd like to talk about really VeloCloud and Arista. So why did Arista acquire VeloCloud? Well, really the idea was to bring together global leadership in the data center and campus networking with global leadership in SD-WAN. So combining Arista global leadership in data center and campus networking with VeloCloud global leadership in SD-WAN. And really the next slide paints the picture really in a bit more detail really. So Arista is very strong in branch, campus and data center networking, but there is a gap, as we can see there, there's a gap between the branch and the campus and data center. And SD-WAN, VeloCloud specifically, fills that gap. So now we can go from the branch to the campus and data center with a single Arista solution with the acquisition of VeloCloud, as I say. So it brings together, a very strong player in the SD-WAN market with, the existing strength of Arista Networks in terms of branch, campus, and data center networking. So that's really the why. Why did Arista acquire VeloCloud? Now maybe we can talk about the how. Just one slide here to talk about the strength, really, to reiterate the strength of VeloCloud SD-WAN. VeloCloud held a leadership position in the Gartner Magic Quadrant for 7 consecutive years. So that was through, various acquisitions of VMware, then Broadcom, now Arista. We've consistently held that leadership position in the Gartner Magic Quadrant. So really it's a testament to the technology itself that not only have we held that position for 7 consecutive years, our customers love us as well, as you can see on the right-hand side there in terms of the Gartner Peer Insights. So I've talked about the why. Let's talk about the how now. So what I'd like to do now is really give you a brief overview of the VeloCloud SD-WAN solution, the components, and then we can talk about the differentiators in terms of our technology. So there are only 3 architectural components of the solution, and this slide here paints the picture quite well, really. So we have the orchestrator, which is that single pane of glass. The orchestrator at the top here is that single pane of glass. Everything is done from the orchestrator, whether it's configuration, monitoring, reporting, troubleshooting, all done from the orchestrator itself. The second element of the solution are the VeloCloud SD-WAN gateways. And the gateways perform 2 important functions, and I'll talk about this in a little bit more detail, but they perform 2 important functions, one in the control plane and optionally in the data plane. And when I say optionally, I mean it's a licensed feature to use the gateways in the data plane. And the third element of the solution are the edge appliances themselves. And we have a wide variety of edges in terms of the physical form factor, if you like. And I'll have a slide on this to talk about that in a bit more detail. But you can consume, there's flexibility in how you consume the edges themselves, whether that's, as I say, a physical appliance or whether it's virtual, or you can deploy the edges in the hyperscalers environments directly. So whether that be GCP, AWS, Azure, etc., it's very a simple and largely automated process of deploying the edges into the cloud environment. As you can see here, the edges build the SD-WAN overlay across whichever underlay is available. So the solution is completely transport agnostic. We will build the SD-WAN overlay across whichever underlay is available, whether it's private MPLS, broadband, cellular, satellite, irrespective of the underlay, we will build the overlay across whichever underlays are available. Another important point to point out here is that the gateways, as I said previously, are actually part of the SD-WAN overlay. So in that respect, that allows us to use the gateways as an on-ramp to SaaS IaaS services, but also integrate with best-of-breed SSE vendors as well, the likes of Zscaler, for example, Palo Alto, Symantec. So if I just go into the 3 components in a little bit more detail, again, these are the 3 components, the orchestrator, the gateways, and the edges. As I said, the gateways, the orchestrators are that single pane of glass. So everything is done from a management perspective from the orchestrator, whether it's configuration, monitoring, reporting, troubleshooting, all done from the orchestrator. The orchestrators are multi-tenant, so we can run multiple ourselves, VeloCloud, Arista, and our partners can run multiple customers on a single orchestrator. They're cloud-based portals as well. So we have hundreds of these orchestrators across the globe, located in top-tier POPs across the globe, really. They were built with API-first design. So essentially, anything you can do on the orchestrator, you can automate via APIs as well. So it's an important distinction, and many of our customers automate many processes using the APIs available on the orchestrator. The second element of it, as I mentioned previously, are the gateways. And as I said, the gateways perform 2 important functions, one in the control plane and optionally, as I said, in the data plane. From a control plane perspective, the gateways act a little bit like BGP route reflectors in that edges announce their routes to the gateways, which then reflect those out to the rest of the network. And that's essentially how the routing table is built. The edges announce their routes to the gateways, which then reflect those routes out to the rest of the enterprise. Like the orchestrators, the gateways are multi-tenant. They're located in top-tier POPs across the globe, as I said, just like the orchestrators. We have in excess of 3,000 gateways across the globe. And the fact that they're strategically located in top-tier POPs, that means essentially because you can use the gateways in the data plane, because they're part of the SD-WAN overlay itself. The gateways are in those POPs, which have high throughput, low latency connectivity to effectively the internet backbone. So using the gateways in the data plane is a big differentiator between VeloCloud and the competition and our competition, because you get the benefit of SD-WAN from the edge to the gateway itself, and then use the gateway as an on-ramp to the cloud. And then we have the third element, which I discussed earlier, the SD-WAN edges. The edges, as I say, are those CPE replacement devices. They sit at the edge, at the branch, at the data center, in the cloud. There's a wide variety of choice in how you deploy the edges themselves, whether it's a physical appliance or virtual appliance running on ESXi or KVM, for example. And as I said earlier, you can easily deploy the edges into the hyperscalers environments. You have zero-touch deployment as well, so it makes it very simple and easy to provision an edge, bring it up, and have it part of the network within literally a few minutes. So those are the three elements of the solution, which makes a very simple solution to consume. And keep in mind that two of the elements, the orchestrator and the gateways, are actually cloud hosted, managed by Arista, VeloCloud, and our service provider partners across the globe. In terms of global coverage, I've talked about this in terms of our POPs. So you can see on the slide here that we have 150 plus POPs between ourselves and our service provider partners, in excess of 3,000 gateways across the globe. And we have a global coverage in terms of both orchestrators and gateways. So it's a very widely dispersed solution, with the capability to have a truly globally deployed SD-WAN solution. To talk a little bit the edges in more detail. So as I said earlier, we have flexibility in the deployment options, whether it's purpose-built hardware, virtual edges running on ESXi or KVM, or indeed, as I said earlier, deploying into the public cloud as a virtual edge. And as I mentioned earlier, the process of deploying edges into the public cloud is a largely automated one. So again, for ease of use and simplicity, it's perfect for that use case. In terms of the hardware portfolio, in the last year or so, we've undergone a refresh of the entire hardware portfolio. So you can see here that we've, with the 700 series, 710, 720, and 740, we've got various different T-shirt sizes, if you like, in terms of capabilities and functionality. So with the 710 5G, we have 5G capabilities built into the edge. So that could be a good use case for that. Could be a pop-up branch. At the other end of the scale, at the campus and the data center, we recently announced in the last 6 months or so the Edge 4100 and Edge 5100 platforms, which have, with the 5100 as 100 gig throughput on, and can be deployed at a data center, for example. So in a very large deployment with high throughput requirements, we would recommend you go with the Edge 5100 with its 100 gig capabilities. So just really as a reminder, we've got lots of choice and flexibility in terms of the hardware portfolio, from the small branch 710 with 1 gig throughput, all the way up to the 5100 with 100 gig capable throughput at the data center. So again, a wide variety of choice in terms of the hardware portfolio. So now I've given you a sort of overview of the solution, the components, the orchestrator, the gateways, and the edges. I'd like to talk a little bit more about the key differentiators of our solution. And these can really fall into 3 buckets, if you like. Best user experience, remediation techniques using DMPO, or dynamic multipath optimization, which is our secret sauce really, and then lower total cost of ownership And I'll give you some examples of each of these as I go through the presentation. But first, if I talk a little bit about best user experience. So what makes us different in terms of many of our competitors is that we use a real-time tunnel performance measurement, something called VCMP, or the VeloCloud Management Protocol. And essentially what this allows us to do is actively measure the performance of the underlay in near real time. And the way we do that really is we add instrumentation, a sequence number, and a timestamp to every single packet that traverses the network. So we're adding the sequence number and a timestamp as part of the VCMP header. That allows VCMP to actually measure things like packet loss, latency, jitter across the overlay. And because we do that unidirectionally, so we do that in both directions, upstream and downstream, that gives VCMP, allows VCMP to build a picture of the health of the network at any given moment in time. Now, what happens if there is no user traffic? So remember, we're adding this header with the sequence number and timestamp to every packet that traverses the network. If there is no user traffic, we will actually use a heartbeat, which is sent every 100 milliseconds, to measure the health of the network whilst there is no user traffic on the network. So whether we have, using VCMP, the VeloCloud Management Protocol, we can have a picture in real time or near real time of the health of the network constantly across all links. So we're doing this, it's not synthetic traffic that we're using, other than if there is no user traffic on the network, but we're leveraging the user traffic on the network to measure the performance of the network. Having this information then allows us to build upon that and I'll come into this in a minute or two. It allows us to then make decisions on the best path for a given application at any given moment in time. So this is a big differentiator between us and our competitors, VCMP. Really, that drives best user experience because we have those measurements. We can then make decisions on the best path for a given application. We also have deep application recognition, a deep application recognition engine built into the software. So a DPI engine based on Quosmos. That feeds into a learning database as well, so we can cache the results of the DPI engine. And having that application recognition allows us to, from a business policy perspective, for example, you can build your business policies or your firewall rules based upon application names and not necessarily, IP subnets, protocols, port numbers, etc. We also subscribe to a cloud services directory with an up-to-date database of cloud service IPs. So the likes of Microsoft, Office 365, etc. We have an up-to-date database of those IPs, which then allows us to obviously recognize those applications too. So, bringing together the VCMP, having that ability to measure the health of the network at any given moment in time, and deep application recognition, again, drives best user experience. Having that deep application recognition also allows us, from the VCO perspective, to be able to report on applications traversing the network too. So a deep understanding of the applications that are running through a customer's network. Now, all of these, so the previous two examples I've given, VCMP and the application recognition, really feed into something called dynamic multipath optimization. So DMPO is our secret sauce, really. And DMPO, again, is leveraging VCMP and the application recognition engine to deliver on three things, really, as you can see here. Continuous link monitoring, so DMPO is using VCMP to constantly monitor the links. It can then use that information on a per packet basis. So again, a differentiator, our technology is per packet. So on a per packet basis, we can steer traffic from one link to another if we detect there are issues in the network. DMPO can also aggregate bandwidth for single flows. So if you have a single flow, we can actually aggregate links together for higher throughput. And then on-demand remediation. So if there are, if you have concurrent degradation, for example, packet loss on multiple links, DMPO can mitigate against that. It can use various techniques, and I'll get into this in a bit more detail. It can use various techniques to overcome packet loss, for example. So it can use forward error correction or packet duplication to overcome packet loss on a link. It's important to remember as well that DMPO is performant on a single link as well. So you don't need to have multiple links to get the benefit of DMPO. DMPO will also work on a single link. I'll show you that in a few slides. So those are the, DMPO is a big differentiator for VeloCloud, performing these three functions: continuous link monitoring, dynamic per packet steering, and on-demand remediation. So going into the on-demand remediation in a little bit more detail, you can see here that based upon, and this again feeds in from the ability to recognize applications, DMPO uses various different mitigation techniques dependent upon the type of traffic. So you can see here that our traffic classifications fall into three areas, if you like: real time, so voice and video; transactional; and bulk, so email, for example. And depending on the type of traffic, we will use a specific mitigation technique. So only for real-time traffic, so voice and video, will we use packet duplication. It doesn't make sense to use packet duplication for transactional or bulk traffic. That would just, clog up the links, if you like. We would oversubscribe the links if we did that if we duplicated packets for transactional and bulk traffic. Again, just like packet duplication for jitter buffering, it only makes sense to do that for real-time voice and video traffic. So there's lots of intelligence built into DMPO in terms of how we, or how it rather, mitigates against issues in the network. So for example, for bulk and transactional traffic, we will use NAT for negative acknowledgement to overcome packet loss in the network. Again, it's based upon the applications themselves. So there's lots of intelligence built into DMPO in that, you don't turn on packet duplication on a link. It's done automatically on a per application basis. So again, a big differentiator with our competition. Just an example of load balancing. So our technology, DMPO, does it in an intelligent way. So if we can allow a single flow to spill over to another link to maximize the available bandwidth. And this is done on a per packet forwarding decision. The link itself is chosen based upon the link latency and the queue depth. So we're not blindly, or DMPO isn't blindly just load balancing traffic across a link. It's done intelligently to maximize the available bandwidth, and based upon the lowest latency link. So again, an important differentiator there. For real-time traffic and a single link here, you can see that the DMPO, when it detects packet loss in the network, the DMPO will dynamically duplicate packets for real-time flows when packet loss is above a specific threshold. So DMPO detects, because remember, in the header, in the VCMP header, we have a sequence number, which obviously that allows us to measure, or allows DMPO to measure packet loss. If DMPO detects packet loss for real-time traffic, it will actually start to duplicate the packets across a link, whether that's a single link in this case, or multiple links as well. And that allows us to, or allows DMPO to mitigate against packet loss in the network. It's important again that if the receiving end receives any duplicate packets, it will discard them again because of the sequence number in the VCMP header. So keep in mind that this technique is for real-time traffic. So only for real-time traffic will we duplicate packets. And this slide here, sort of this little video here, if you like, talks about DMPO in action. So we're running a video conference over a WAN link. So it's a single link here with 2% packet loss. On the left-hand side here, you can see that we've got without VeloCloud, the video is highly pixelated. On the right-hand side there, we can see with VeloCloud. So again, this is on a single link with 2% packet loss. Obviously, what's happening here is that DMPO is detecting the packet loss, the 2% packet loss. It's duplicating the packets to the receiving end, and the stream is, perfectly usable. I think, on the left-hand side there, we would probably all drop from the call or stop our video. But with VeloCloud here on the right-hand side, it's a perfectly usable video stream. So remember, keep in mind that we're only doing this. You can have multiple applications running across the same link, but only will we do, packet duplication for real-time traffic. Now, if we move on slightly from DMPO, so out of the box, the VeloCloud software comes with something called smart defaults. And again, this relies upon the ability to recognize applications. So the smart defaults, so they're called smart defaults because out of the box, we have business policies predefined to get customers started. So immediately they can get the benefit of the technology without configuring, without necessarily understanding all of the applications through their network. Straight out of the box, when you provision an edge, you inherit these smart defaults. And the smart defaults, as I say, are being built by VeloCloud over the last 10 years or so, using our experience with our customers. So we automatically identify a number of applications, as you can see here. So we've got different rules, and based upon the application, we're applying different actions, things like prioritization, whether a traffic is high priority, etc. So immediately you provision an edge, you inherit these smart defaults. That allows you to immediately get the benefit of VeloCloud SD-WAN. So, and that really effectively leads to lower total cost of ownership because we have these smart defaults. As I say, you can immediately get the benefit of the solution as soon as you provision an edge. Obviously, you can modify these smart defaults, or you can add your own business policies as well. But in reality, many of our customers go with the smart defaults because they're, being tuned by us using our experience of our customers over the last decade or so. So now I'd like to, now that I've given you a sort of overview of VeloCloud SD-WAN, I'd like to talk in a little bit more detail about secure SD-WAN. So over the last few releases, and it's probably fair to say that one of our gaps really in terms of our software was really in the realm of security and onboard security. We've always had a application-aware stateful firewall. That's always been the case, but we were lacking some next-gen firewall capabilities. But as I say, over the last few, probably over the last year or so, we've introduced something called the Enhanced Firewall Service onto our edges. And the EFS service, the Enhanced Firewall Service, now includes IDS, IPS, URL filtering, and malicious IP filtering. So now we're moving towards more like next-gen firewall capabilities on our edges. We'll actually be adding, and as a key focus of ours over the next probably 6 to 12 months, is adding additional capabilities when it comes to firewalling on the edge. So for example, we'll be leveraging Arista's existing firewall platform to add things like TLS termination on the edge, a beta of which will be out in sort of Q1 next year. So it's a big step forward for us in terms of security capabilities, is that we now have this EFS capability on our edge appliances themselves. Now, in terms of integrations, now obviously, as I'm sure you're all aware, that SASE is a big, is making big leaps forward. Many customers are moving to cloud security platforms, really, and the approach that VeloCloud has decided to take, and certainly since the acquisition by Arista, is to have best of breed integrations. So best of breed SSE and best of breed SD-WAN, i.e. VeloCloud. And the way we've gone about this, really, and much of this has been available for a long time, but there are two options in terms of integrating with SSE vendors. One is via the gateways. So again, recall when I gave the introduction, I talked about how you can leverage the gateways in the data plane. Well, in terms of, in terms of using the gateways, we can actually build IPsec tunnels from the gateways to the SSE vendors, whether it's Zscaler, Symantec, Palo Alto, etc. In the case of Symantec, we've also got multi-tenant GRE tunnels built to Symantec, and we're looking to enhance these integrations. So, for example, with the likes of Zscaler, we have lots of automation to make the process of integrating with Zscaler in this case as simple as possible. So there's lots of automations in terms of building these tunnels from the gateways into Zscaler. The benefit, one of the big benefits of using the gateways as an on-ramp to your SSE vendor, is that you get the benefit of DMPO from the edge to the gateway itself. So recall, you get all of those great features, link aggregation, you get mitigation against packet loss, etc., from the edge to the gateway. So that's one of the main benefits, really, of using the gateways, both for SaaS services, but also for integration with cloud or SSE vendors too. So again, you get the benefit of DMPO from the edge to the gateway. So that's the first element of integration when it comes to integrating with SSE vendors. The second option is directly via the edge itself. So you can build tunnels, IPsec, from an edge directly to the SSE vendor's environment itself. We also support, as you can see here, GRE for Zscaler only. In terms of automations, again, with Zscaler, we have a largely automated process of integrating with Zscaler, and we're looking to expand upon that with other vendors, Palo Alto, Netskope, and Netskope, for example. As you can see here, there's no DMPO, so you lose the benefit of DMPO from the edge to the gateway, but you're going direct from the edge into the into the SSE vendor's environment. One thing to bear in mind as well is that you build these tunnels and then you use the business policy on the edge to direct traffic from or direct traffic to the SSE vendor itself. So you use the business policy on the edge to direct traffic or redirect traffic to the SSE vendor. So you can pick and choose which traffic you want to have sent to the SSE vendor for further security analysis. You can also use the business policy to send traffic direct if that's what you need. If you have trusted traffic, for example, you could send that direct and not send it via the SSE vendor. So lots of flexibility in how you send traffic to the SSE vendor environment. So again, just to summarize, in terms of integrations with SSE vendors, you have two choices via the gateway. The benefit of that is you have the protection of DMPO from edge to gateway, or you can go directly from the edge using IPsec or GRE for Zscaler. Now, just going into a little bit more detail, I suppose, in terms of SSE, Gartner have produced this list of integration levels from basic all the way to data plane intelligence. And we're, in terms of some of our vendors, for example, Zscaler, we're quite away in terms of integrations. So you can see for Zscaler, we're 1 to 4, and then 6. So we've got lots of integrations when it comes to Zscaler, as we do with Symantec as well. And we're building upon this, as part of our strategy, best of breed SD-WAN with best of breed SSE. So this is our integration status as I speak. But as I say, we're adding to this. And for Zscaler, we're looking to add additional capabilities in the relatively near future. It's worth also pointing out that if you use a SSE vendor, which isn't on this list, that doesn't mean that we can't integrate with them. You can build an IPsec tunnel from the gateway or from the edge to basically any third party. So there's, we can effectively integrate with any SSE vendor. So really, that's the end of my presentation. But one thing I would really like to sort of say and keep in mind, really, in summary, the benefits of VeloCloud SD-WAN. So taking it from the left-hand side, really simplified WAN operations. And what we mean by that is having that single pane of glass, the orchestrator, for monitoring, reporting, troubleshooting, end-to-end analytics. Vastly reduces the overhead on the operations team. So you can view all of your configurations, all of the performance of your network from a single place. And as we move forward with Arista, we'll be seeing, and you will be seeing, additional integrations between VeloCloud and the wider Arista portfolio, starting with some integrations with CloudVision. Assured application-based clause. So again, keep in mind that our sort of secret sauce is DMPO, dynamic multipath optimization, which is really an amazing technology in terms of its ability to detect issues in real time and in a few hundred milliseconds move traffic from one link to another in the presence of brownout or blackout conditions. So that's a very big differentiator for VeloCloud, compared to our competitors. And then finally, ease of cloud adoption. And cloud adoption could be integrations with the hyperscaler environments, whether that's AWS, Azure, etc., or indeed integrations with SSE vendors such as Zscaler, Palo Alto, etc. So really, the ability to integrate your environment into the cloud is unparalleled, really, with using VeloCloud. And again, that largely falls back into our architecture. So you having the gateways in POPs around the world with high throughput, low latency connectivity to effectively the internet backbone allows us or allows customers to leverage those gateways to get to the cloud as quickly as possible. And obviously you can deploy edges directly into the cloud environment. So really that completes my presentation to this webinar from my perspective. I'd like to thank you for your time. And if you have any questions, I'd like to answer them.
Thank you so much, Robert. At the moment,
Thanks,
there are no
Stephanie.
questions in the chat, but yeah, you're now able to ask them. If not, you can also ask the questions via email after our follow-up mail. So, and then we will answer the questions.
Yeah, please, if you have any questions, I can answer them live. I've blown you all away with my presentation.
Then, Robert, I would say if there are no further questions, thank you very much for your time and for the presentation as well. And yeah, then I will, oh, thank you, Oni. Okay.